Dear friends, thank you for joining me once again in this new chapter. Your vitrectomy is done. You will now color the tissues to be removed. Why do you need to inject a dye? For nearly 20 years, I have removed just over 12,000 ILM without using any dye. I was able to do it because I did not use intraocular fibers, which illuminate the macula at an angle of 25 degrees and therefore do not reflect the reflections of the membrane, but the operating slit lamp of the microscope placed at 5 degrees, which in turn send back all the reflections to the operator. This is how I discovered why it was necessary to remove the ILM. Without the slit lamp, I could not have introduced this concept. I realized at the time that apart from the treatment of metamorphopsia, it was useless to remove these reflective plaques, which correspond only to the posterior haloid, invaded by and disorganized by a glial proliferation. However, we have discovered with my pathologist's wife that it was necessary to exert a mechanical trauma to cause a retinal reaction, and that the best way to do this was to remove the ILM, since it is always accompanied by a tearing of the mular cell hand feet. This trauma induces a restorative response that leads to visual improvements far superior to any other treatment. To avoid unnecessary manipulation, I started by catching the ILM outside the reflective areas where the haloid was attached to make a rhexis surrounding the reflection. This is to say, removing at the same time the ILM, the glial proliferation, and the haloid plaque. That was quite easy for me, since once again slit lamp lighting allowed me to see the reflection emitted by the haloid fibers and thus to determine the areas where I could start the peeling. In fact, I used the slit lamp as can be used triamcinolone, which also allows us to identify areas covered with hyaloid. But as I told you before, I stopped triamcinolone or Kenacort when I found that visual improvements were worse when it was used. In addition, the crystals could also interfere with the ILM peeling by interposing in the jaws of the forceps. My only indication for triamcinolone was high myopic eyes, for example in myopic macular holes, or some cases of retinal detachments. I also did not use the indocyanine green because of its toxicity problems, nor trypan blue, which colors everything including vitreous. Understand that I had no interest in making colorations that add a complicated extra gesture and that does not have the selecting coloring properties, unlike what showed me the slit lamp. But I must humbly admit that when I started using the Coomassie Blue staining, I realized that during 20 years I have been done incomplete and sometimes even too traumatic peelings, so error by default or by excess. In fact, the benefits of this specific staining are very interesting and useful. Indeed, Coomassie Blue is a dye that has interaction with amino acids such as phenylalanine, tyrosine, tryptophan, arginine, in short what are called membrane proteins found in cell membranes. cytoplasmic membranes, mitochondria, Golgi bodies, or endoplasmic reticulum. By definition, the Coomassie Blue will not color the posterior haloid and the vitreous, which are collagen II fibers. It will not color either the ILM, which, despite its name as a membrane, is not a membrane but a collagen IV structures or a structure of 1 micron thickness. But the ILM is so porous that the staining will be able to bind into the membrane protein of the Muller cell and feet on which it rests, as well as to the membrane protein of the astrocytic proliferation which crushes it. Your goal being to remove the Muller cell and feet, Coomassie Blue will therefore mark exactly what you want to remove without coloring the rest. Of course, the trypan blue will also stain the feet of the Muller cells. But since it will color the haloid at the same time, you will not know if the place where you attack the dissection is pure ILM or if it is covered with haloid. It's like putting on infrared glasses in a dark nightclub. You see all the dancers very strongly, but you don't know if the person you are going to invite is male or female. Not only is Coomassie Brilliant Blue less toxic than the other retina dyes, but it will also identify the target. Imagine a system that would selectively identify terrorists in the middle of a crowd. It would still simplify things a lot. So let's take a look at the benefits of Coomassie Brilliant Blue coloring. First of all, as I told you, the fact that the blue of Coomassie marks the Muller cell and feet, but does not mark the posterior haloid, which will appear in negative staining, will allow you to immediately understand the situation. When there is no blue color at all, you will know immediately that the retina of the posterior pole is covered with haloid. You are in the case of either an absence of PVD or a vitreoschisis. And you know that if you try to create a plane of cleavage, you may spend a large time because the forceps will slip on the fibers and remove only small fragments without consistency. The risk is to get nervous, to want to pinch more than reason, and to do something stupid. You may choose to start by creating a plane of cleavage with a sharp pick or a curved needle if your choice of gauge allows it. When there is a uniform blue color without unstained islands, you will know that you are in the configuration of pure edema. You will then choose your most accurate forceps and start peeling where you are more comfortable. When you see one or more unstained islands on a bluish background, you will know that you are in the classic situation of the epiretinal membrane, and you can then either choose to remove first the posterior haloid plaque by approaching it on one of its edges, and in a second step you can remove the ILM without worrying about the haloid. For more comfort, you can re-inject the Coomassie Brilliant Blue for better staining and to control under the haloid plaque. Or you choose to remove the haloid and the ILM in one single step in order to save instruments entrance and exit. You can then very easily choose a range of pure halogen-free ILM close to the haloid plaque with enough wide enough to be able to achieve the departure of a large rhexis with a sufficient strong lever arm. So you will remove at the same time the hilum and the overlying haloid. Sometime before the marking, you will not see anything extraordinary except images of what was once called axoplasmic interaction zone, and suddenly the injection of Coomassie Blue will reveal that the marking stops abruptly at a separation zone of an RC form. In fact, the staining shows that beyond this zone there is no more hilum and Muller cell hand feet, as Etienne Beauvais has very well described. The contraction of the membrane spontaneously ripped off the torque hilum glial cells, and the ripped area wrapped around itself. If we did not make this diagnosis with the dye, we could start the peeling in the wrong side and we would then attack directly the axon plane. The dye, in this case, avoid an error by excess. Sometime finally you will have the impression of having removed a well-colored hilum, and you may feel as if the peeling is finished. It's in cases like this where before I use the dye I certainly had to stop the peeling too early. If we take the habit of re-injecting Coomassie Blue whenever there is a doubt about the entire peeling, we can avoid errors by default and discover, as here, that we had not removed the hilum. So we had not traumatized the retina and we had not done the job. Here is another example, even more demonstrative, where we could very well feel that the work is completed after the first peeling. There are indeed cases, as I said in chapter 1, where the astrocytic proliferation is so strong that it can proliferate from the haloid plaque and form centrifugally and above the hilum plane a neomembrane simulating a second hilum, as the astrocytic proliferation has the same coloring properties as the hilum. This is exactly what happened in this eviscerated hive that my wife Yvette was able to examine, where we see that the pseudomembrane made only of astrocytic cells labeled by the anti-GFAP antibody extended horizontally from the haloid plaque above the hilum and simulated, giving the identical marking, a second hilum. In fact, these cases are just the more advanced stage of astrocytic proliferation that this classical stage of epiretinal membrane, where we see on the nasal edge of the haloid plaque identified by the negative staining, an astrocytic proliferation intensely marked in blue and proliferating on the posterior edge of the haloid, which will extend centrifugally over the internal limiting membrane. After removal of the haloid plaque, it can be confirmed that the plane formed by the torque hilum Muller cells was intact. It is therefore important to keep in mind these cases so as not to hesitate to re-inject the Coomassie Blue whenever there is any doubt. This will prevent some people from saying that they have had an epiretinal membrane recurrence, which is impossible since the hilum cannot grow back because it's not a cellular structure, and that the haloid carpel will not reproduce. Simply, their first peeling was incomplete for the reason we have just seen. So you see why a defender of the peeling without coloration could have become addicted to Coomassie Blue staining because of the contribution to the understanding of the pathology it allows. And all in all, having a better image thanks to the plano-concave lens, greater gestural precision thanks to the slit lamp, and better understanding thanks to the blue of Coomassie. All this combined makes you have a better control, which is a secret to save time and trauma. Now let's go to some technical advice. Since you are going to inject the Coomassie Brillant Blue twice, first inject only half of the flask. You do not have to do special manipulation for the injection. Inject in the middle of the eye. If, like me, you have done only a posterior vitrectomy, you can still make your injection in the middle of the eye because you have no risk of coloring the vitreous. The only risk is to inject too hard by creating a Karcher effect that can cause a retinal tear. I therefore advise you first not to place the tip of your injection cannula too close to the retina. Secondly, to take the dye in a tuberculin syringe so that the injection pressure is more controllable given the length of displacement of the piston. Let the dye rest for a longer or shorter period depending on the intensity of marking you want to obtain. Personally, I did not see the need for a very pronounced marking, and I did not leave the dye in place for more than 10 seconds. To remove it, I advise you to place your handpiece to 1 or 2 millimeters from the dye and aspirate while verticalizing the infusion with the other hand. A circular current like that of a washing machine will then occur. As it rotates, the blue will rub the Muller cells of the posterior pole and the staining will increase. Repeat the same technique after re-injection at the slightest doubt. Here is what I wanted to tell you about dyes. We will conclude these chapters on macular edema surgery by addressing in the next chapter the techniques of peeling.